You are driving down the street in your Honda Civic, or maybe cruising in a heavier Ford F-150. You suddenly see a massive crater of a pothole right in your lane, and your immediate instinct is to slam your foot on the brake pedal and hold it there right into the hole. That split-second reaction is completely destroying your front suspension, and it is a mistake almost every single driver makes. When you stand on the brakes, the entire weight of your vehicle shifts violently to the front axle. Your front coil springs compress completely, and the hydraulic shock absorbers bottom out. The suspension becomes completely rigid because all the fluid inside the shock is already highly pressurized from the weight transfer. When your tire hits the sharp edge of that pothole while the suspension is fully compressed, there is absolutely zero travel left to absorb the impact energy. You have created a hydraulic lock. It is like taking a heavy sledgehammer directly to your lower control arms, your expensive aluminum wheels, and your upper strut towers. The kinetic energy bypasses the springs entirely and hammers the unibody chassis of the vehicle. If you do this in a low-slung sports car, you will easily bend a rim. If you do it in a heavy 5,000-pound SUV, you can physically bend the steering knuckle. The trick that experienced performance drivers and mechanics use is to brake hard when you first spot the road hazard, but completely release the brake pedal a fraction of a second before the front tires drop into the hole. This sudden release allows the weight to transfer back to the center of the car, the coil springs decompress, and the suspension regains its full range of motion to actually absorb the hit exactly how the engineers designed it to. It will save you thousands of dollars in bent rims, blown-out strut seals, and unnecessarily activating the anti-lock braking system. But let us say you have been driving over rough, neglected city roads for a while, and now every time you go over a small crack in the pavement, hit a speed bump, or pull into your driveway, you hear this annoying, hollow clunking sound coming from the front end. Most people immediately panic and think their entire steering rack is falling apart, their engine mounts have collapsed, or their CV axles are shattered. 9 times out of 10, that maddening metallic clunk is just a worn-out sway bar end link. The sway bar is a thick torsion spring that connects the left and right sides of your suspension to keep the car from leaning over like a boat when you take a corner. The end links are the small metal rods with ball joints on each end that connect that thick bar to your struts or control arm. Over time, the internal plastic sockets inside those tiny ball joints wear out from the constant up and down motion, and the metal ball starts rattling around inside the metal housing. You do not need to wait for them to sound like a bucket of loose bolts to do something about it. It is incredibly smart to proactively replace these links around 45,000 to 55,000 miles, depending on how punishing your local roads are. And when you go to the auto parts store, always ask for the heavy-duty greasable versions. They have a little Zerk fitting on the back so you can inject fresh grease every time you change your oil, pushing out the old contaminated grease and moisture. But before I tell you the massive installation mistake amateur mechanics make that instantly destroys these new parts in the driveway, do me a huge favor and hit that subscribe button so you never miss out on these real garage diagnostics and repair secrets. Here is the massive mistake people make when installing any bushing-based suspension part. They jack the car up, let the front wheels hang completely off the ground, install the new sway bar links or control arms, and grab their impact wrench to torque the bolts down as tight as possible while the car is still up in the air. If you do this, you are locking the rubber suspension bushings in an unnatural, fully drooped position. When you finally put the tires back on and lower the car, the full weight of the vehicle instantly twists and tears that brand new rubber. You have created what mechanics call suspension bind. You have to hand tighten the bolts while the car is in the air, but you absolutely must put the tires back on, lower the car so the full resting weight is on the ground, and only then do you get underneath to torque the bolts to the factory specification. Doing it this way ensures the rubber bushing is resting in its natural, neutral state when the car is driving down the road. This single installation detail will literally double the lifespan of your new suspension components and prevent that annoying squeaking sound over bumps. While we are on the topic of strange front-end noises, let us talk about a completely different sound that tricks people into spending massive amounts of money at dishonest repair shops. You are sitting in a parking lot, the car is barely moving, and you turn the steering wheel to back out of a spot. Suddenly, you hear a loud, metallic boing or a heavy popping noise that vibrates right through the steering column and into your hands. Shady repair shops absolutely love this noise because they will look you dead in the eye and tell you that your power steering rack is destroyed or your steering column needs to be replaced. The truth is usually sitting right at the very top of your front suspension. On a McPherson strut setup, which is the suspension design that 90% of modern commuter cars use today, the entire strut assembly has to physically rotate left and right when you turn the steering wheel, to allow this massive coil spring and shock to rotate smoothly under the weight of the engine. There is a small, inexpensive plastic bearing at the very top of the strut mount, hiding right under the hood. Over the years, acidic rain, harsh winter road salt, and fine dirt wash the factory grease right out of that bearing. It rusts solid. When you turn the wheel, the bearing refuses to spin, which forces the massive steel coil spring to bind up and twist like a giant rubber band. When the mechanical tension gets too high, the spring violently slips within its rubber seat, making that loud popping noise. It can even cause your steering wheel to feel extremely heavy, or make the car pull to one side after completing a turn because the bearing is stuck in the rotated position. You do not need a new steering rack. You just need to pull the struts out and replace those upper strut mount bearings for $30. It is a brilliant example of why understanding the actual mechanical problem is so much cheaper than blindly throwing expensive parts at a vehicle. I am about to explain the biggest, most dangerous mistake people make when buying replacement suspension parts that will literally make your car violently pull you into oncoming traffic during an emergency. But right before we get into that critical safety warning, take a second to subscribe to the channel if you are getting serious value out of this garage talk. Let us say you finally find that bad shock absorber or that blown out ball joint on the passenger side. You go online, you order one single replacement part for $50, you bolt it on a Saturday afternoon, and you think you are an absolute mechanical genius. You just committed the ultimate suspension sin. You must always, without exception, replace suspension components in pairs across the axle, left and right together, every single time. Think about it logically. If your right shock absorber has been bouncing down the road, absorbing millions of micro impacts for 60,000 miles, the left one has been doing the exact same amount of work. It is equally exhausted. If you put a stiff, brand new, highly pressurized gas shock on the right side and leave a tired, worn-out, soft shock on the left side, your car's handling dynamics will be completely destroyed. The vehicle will exhibit severe asymmetrical behavior. When you hit the brakes in a panic situation on the highway, the stiff side will grip the road and stay planted, but the soft side will dive dramatically toward the pavement. The car will violently pull to one side, potentially throwing you completely out of your lane and into the median. Furthermore, your vehicle's electronic stability control system relies on predictable, symmetrical chassis movement to keep you safe. If one side reacts completely differently than the other, the computer cannot save you in a skid. Plus, the brand new part is now going to work twice as hard trying to compensate for the weak, dying part on the other side. That new shock will blow its internal seals in half the time it normally would. Whether it is coil springs, tie rod ends, lower control arms, or shock absorbers, you are dealing with the physical geometry of a heavy machine traveling at 70 miles per hour. Keeping the damping forces perfectly symmetrical across the axle is the only way to ensure predictable body roll, safe braking distances, and perfectly even tire wear. The labor required to tear down the suspension is exactly the same on both sides, so never cheap out by doing just one side. You are not saving money, you are actively compromising the safety of everyone in the cabin. And speaking of perfectly even tire wear, the absolute fastest way to incinerate a brand new set of expensive tires is by ignoring your wheel alignment after you do any of this suspension work. You would be shocked at how many people bolt on new tie rods or lower control arms in their driveway, eyeball the steering wheel to make sure it looks somewhat straight, and drive off thinking everything is perfectly fine. You can have your steering wheel perfectly dead center while your front tires are actually pointing slightly away from each other or pointing inward towards each other. This is called the toe angle. Imagine walking down the street with your feet pointed outward like a duck. That is exactly what your tires are doing. They are not rolling freely. They are literally being dragged sideways down the abrasive asphalt while the car moves forward. Your suspension can handle a bad camber angle for a relatively long time without catastrophic wear. But a bad toe angle is an absolute tire killer. It will physically strip the rubber right off the inside or outside edge of your tires down to the exposed metal wire cords in less than 1,000 miles. The scariest part is that you usually will not feel it in the steering wheel, and the car might even track perfectly straight down the highway, but you are silently erasing hundreds of dollars of rubber with every mile you drive. Anytime you unbolt a steering or suspension component, or if you hit a curb hard enough to bend a steel rim, you have to get the car on a specialized laser alignment rack. The factory specifications for toe, caster, and camber are measured in microscopic fractions of a degree. You simply cannot eyeball it in your driveway with a tape measure and a piece of string and expect it to be factory perfect. Paying $100 for a professional four-wheel alignment is the absolute cheapest insurance you can buy to protect your expensive tires, maximize your fuel economy by reducing rolling resistance, and keep your chassis tracking exactly how the engineers designed it. Maintaining the undercarriage of your vehicle is not just about having a smooth, quiet ride on the way to work. It is the literal foundation of your safety and control on the road. You have to get under there with a flashlight, check for those torn rubber boots, listen closely to what the car is telling you over bumps, always replace parts in pairs to keep the chassis perfectly balanced, and stop panic braking into those massive road craters. I want to hear exactly what is going on with the suspension on your daily driver right now. Drop down into the comments section and tell me what weird clunks you are currently chasing, what parts you have replaced recently in your driveway, or how many miles you have managed to get out of your original factory shock absorbers before they started leaking fluid. Let us diagnose these suspension gremlins together in the comments and figure out the smartest way to fix them. If you learned a new garage trick today and want to keep your ride driving straight, true, and safe, hit that subscribe button, give the video a massive like, and I will see you in the next one.